Okay, so our game was called Bird Game. So the objective of our code was to make a game where you play as a bird or play as a car. And pretty much like if you play as a car on like one device, like on one phone, and you play as a bird on another, and they connect to each other through one server, and they get updated via that server. And the goal was like you tap on the bird and then it like poops on the car. We didn't make it that far, and probably because we didn't have enough fear. But we'll finish it eventually, maybe. So, anyways, all right, so we hosted a server. I created a server class in Java. We hosted that on our student, like our computer school or something. I don't know. And yeah, we're connecting through that server.
Well, it's awkward when it works actually like 20 minutes ago and you're up here in front of people now. I hope you could sympathize.
So yeah, so we didn't have two Android devices, so we had to emulate an Android device with this computer. So you connect to the server as the bird, and then the server says, okay, I know that there's a bird here. And then you connect to the server as a car, and the server's like, okay, now I have a bird and a car, now the game can start. So as soon as you connect to the server, you'll be able to demo it.
I don't exactly know why the simulation isn't working. I had hardware acceleration working earlier.
If it doesn't work, it doesn't work.
Do you want me to just I'll just oh, okay. I mean, I can see you try different things, but I don't want to waste people's time. It's like
we just gotta send it.
I think I'm just going to scrap it and just explain it.
Okay, so eventually, you take over. You got it.
So basically what we did is we had two Android devices. Right now it's not working with hardware acceleration and Android Studio are playing nice with each other. Basically what we did, two Android devices, we had them connect to our server, and in the process of making this, we totally we really rampaged my phone's memory. It was awful. I feel bad for it. But after a while, we got it working. After coffee and beer, we got it to work perfectly. No, it's not, but it's nice to explain it out. But
all right. Right now we have Resi. On deck we have Smiter.
Hello? So, yeah, Hey, our project is ready. My name is Jackie.
Okay.
Hey guys, be quiet while we
You can't hear me? Okay, hello. My name is Yakif. Our project is Resi. This is, I'm Yakif. This is Jason. This is Zakir. This is Cash. I came up with the idea with Resi like about 2 weeks ago, and the project was kind of came as a result of me knowing that like a lot of people my age and like especially like a lot of my older family members who might not have attended college a lot of times don't even really know how to make their own resume. And I realize that's a challenge for a lot of people, especially if you don't go to college. So I wanted to kind of streamline that process. And I thought of the idea of using Google's AI assistant and creating a Google action to supplement that process and export editable resume to Google Docs that they can then go and make corrections to. But it's already pre-formatted, so you don't have to spend hours thinking about how to make it look the best and all that type of stuff. So they're setting it up now. And just to run through, as far as the tech stack goes, it's Google Dialogflow. The back end is covered by Node.js and Google's Firebase. And yeah, it's just some JavaScript.
You're on.
All right, awesome. So, all right, so we're just going to do a demo of our test app. All right, talk to my test app.
All right, here's the test version of my test app. Hi, I'm Resi, your personal resume assistant. Are you ready to write your resume? What is your name?
Jason Scharf. Jason Scharf.
What is your email?
jasonsharf3@gmail.com.
What is your address?
123 Main Street. 123 Main Street.
What is your phone number?
555-123-456712.
Great, Jason. Are you ready to put in your school information?
Yes.
What is your highest level of education?
Graduated college. Graduated college.
Great. Where did you go to school at?
Syracuse University. Syracuse University.
Get out. When did you start there?
2002.
What year did you stop going there?
2003.
What subject is your degree in?
Interpretive dancing.
What are some classes that you took at school that you want to add to your resume?
Pottery and dental hygienics.
You are a beast. Are you ready to write your experience?
Yes. Yes. Oh,
No, stop it.
Who did you work for?
print. Print.
What year did you start working there?
Print.
Let's keep going.
Keep on. Okay. 2000. Okay.
Jason3@gmail.com.
So then I should-
567.
So what happens is it's gonna take a few moments before we actually see the date. Never mind, it's right there. So
Sweet. All right, do it.
It'll do it. Just give it a second.
you give it a second to actually load the data, and as you can see, so it says his name was Jason, where I live at, and it's gmail.com. We can add a lot more stuff, but because of time, we decided to like only three of them. But it's actually working, practical, and that's something people can actually use to actually create a resume. So the idea is to have a beautiful template with and everything on it, and you could just, hey Google, hey, I want my name there, I want my Gmail, and you fill it out for you. So that's the idea.
Yeah, and then go ahead.
Can you show us your dialogue flow interface?
Do you have it on here?
I think.
Yeah, you have it up
Yeah,
right
yeah.
there.
Oh, is that it? I have so many files open.
Yeah,
so.
let me go through it. Yeah, so is there? So I guess I'll kind of run. Just like you want me to like run through what it does or how it works.
Well,
minute.
Okay, so in terms of the way Dialogflow is powered by the WaveNet, which is the natural language understanding model that Google uses, and that goes from the text to speech and speech to text. And intents are essentially any type of intent that you're serving for the user, and basically like the only functions you have. And this is just a few of them. And then you have entities, and those are specific types of words that are specific to your use case. So we had classes taken, degree, employer, highest level, job description, school name, title. And in terms of fulfillment, that is just that is basically all the JavaScript code that handles any of the outside APIs. So when you connect to Google Docs, we had to do it through fulfillment, and we do it through a webhook, which we deploy to Firebase. So, in terms of just the experience, it was very hard. We were very stressed.
Yes.
I thought it was gonna be like 3 steps and we're done, and no, it was not at all. But it was. I enjoyed it. Huh?
Was easier to write your resume?
Right.
Cool. Well,
Oh,
thanks
that
so
was
much.
it. Thank you, guys.
All right, now we have Smiter. On deck we have Glare.
For my laptop, yeah, we got some time, but automatic means you need so I'll do is yeah. Yeah, sure. Let's do it double check. Okay. So yeah, you just talk about it while I screw it up. Make sure this actually. Not just wait until it actually gets in. Alright, so hopefully my laptop will boot up in time. It can't survive without its own power supply all the time, so my name is Michael Crowley. I'm from SUNY Potsdam. I had the bad idea to make a game solely in Java instead of using an actual game engine. But it was more for practicing my Java skills and for learning things like threading and action listeners and all that good stuff. So my idea was to make a game based on fighting off waves of bad guys, basically. It's an idea I've had for a while. I just wanted to try and get a start on it. She's just not going to do it at all. So it's like, that's cool. I struggled a lot in mostly just getting the assets working. I did find a lot of free assets that I could just download. But like for the background, I had to spend 2 hours just trying to edit one big enough to put together to look nice. But I had kind of lofty goals. I wanted to try and get it to the point where I could get multiple people to connect with a character to join in the fight. I eventually just was able to get it to get everything to show up on the screen that I wanted, which is basically just the player character, the background, and the images. And then it could change animations, which I'll use threading and to run the animations smoothly. Looks like it's not doing anything, so that's alright. So I guess I'm not gonna have anything to show, unfortunately, but I do have up on my repo at github.com/Michael Crowley. So if you're interested in looking at it, it's there. Any questions?
What was the biggest challenge you faced?
The biggest challenge was trying to edit my sprites that I had, just because I'm not good at editing images, and I was hoping I could just download free stuff to use, but I had to edit some of it, and it took a lot longer than I wanted.
I was gonna say, what kind of charger are you using? Because I have a charger.
It's whatever the default model that came with 6 years ago. I don't remember off the top of my head.
Oh, it's not
It's more the laptop itself is just old and doesn't want to boot up fast. So
have glare, and on deck we have time-saving work hacks.
So we made glare. Now we kind of ran into a bunch of difficulties, and it's not really fully up. But we do have something if it doesn't die. But we intend to update it more. But it's supposed to be an app that you basically wake up to and it gives you the daily info that you need, like the weather, like basically like the time and everything. Like you set reminders that would just remind you about things like often, like every hour or so. And it's going to be open source, and like you can add like APIs and stuff like that.
Alright, so I'll explain it real quick. So laptop just died, it was at 6% and it just ended. So I'll explain a little bit on the technical side. It's my first time working with Electron in JavaScript. It uses Node.js as like a backend, which I've used that many times before. But to explain it a little bit more in depth, think about just like imagine, you know, it's a nice morning, you just wake up, you want to like see the news, see the weather, all that kind of cool stuff, all the cool jazz, right? So see all that. And our main goal for this project was to have full customizability. So give the users the ability to like set their own API endpoint so they could have their own dev show up automatically for, let's say, in the morning, you have a timer, all that kind of stuff. So essentially, that was our main goal, just having full customizability, letting the users choose what they want to see, what they don't want to see, that kind of stuff. But it's our first time using Electron. I wish we were able to actually show you guys. There was not much to it yet because we originally were going to use Java, but that was not a very good idea because Swing, I don't like Swing. But yeah, sorry I couldn't show you guys anything, but that was mainly our project. So that's all. Thank you.
Up now we have time-saving work hacks, and on deck we have Project Lord Falcon.
It just occurred to me that I gave my title, I gave my project a generic title, and it's way the opposite. It's super specific. So if you're hoping to save time at your work, I'm sorry, I'm going to fail you. So I spent a lot of time thinking about this chart. One of the things that I learned at this hackathon is that if something's taking you more than a minute or two, you can invest an unbelievable amount of time in automating it. The stuff that I solved is like a minute or a couple seconds. So it's the kind of thing where you do it at a hackathon instead of trying to justify it to your boss. So part of my job is software engineering, and part of my job is supporting other developers. I like engineering a lot more, so I've decided to build some tools to help save time. Not that I don't want to interact with devs, it's just it's more fun to build stuff. So I work at an Ethereum assets marketplace called OpenSea. Developers come to us, they say, hey, I built this new token contract, I have this contract address, will you please add my personal address so that I can be an editor of this contract address? It's just going to need a second. So I spend I do this once or twice a day, and it takes me like 2 or 3 minutes each time, but you know, I would rather spend my time otherwise. So what I did was I used the Etherscan API to access the contract's first transaction, and the from address of the contract's first transaction is the contract creator. So I've authorized contract creators in addition to the contract owner to edit these contracts on OpenSea. So it's like ultra dull, ultra esoteric, a little bit more exciting. I also built a Chrome extension, my first Chrome extension. I call it Etherscan Quick. It's published if you want it. Maybe Doug Press E, press tab, and then copy and paste in either an address or a transaction. And it takes you straight to the Etherscan page. The alternative is typing in Etherscan, dragging, pasting it in. So it's like, this is gonna save me maybe a second and a half per cycle, but I do this a dozen or 2 times per day. One more thing, this is an old hackathon project, Hack Upstate Pickbot. Check it out. The pictures from this event will be up here soon. If I got any time left, where's the timer, Jesse? We have 30 seconds left. I'd like to spend 15 of those seconds thanking Doug, Jesse, and Will for putting a tremendous event on for us. Round of applause for you. So I use Django and I use JavaScript. The Chrome extension was unbelievably easy. I think like the lines of code that I changed were probably like 6, and the lines of code that I wrote were around 4. If you've never made a Chrome extension, I can strongly recommend it. And that's it from me. Thanks for your time. Any questions?
How does OpenSea, like, is it similar to CryptoKitties?
So yeah, so like imagine that CryptoKitties is like Hasbro. They make stuff, they sell stuff themselves, but they also sell stuff on Amazon. We're Amazon to Hasbro. So we're OpenSea, they're CryptoKitties. They create stuff. We provide a place where users can sell peer-to-peer.
Now we have Project War Falcon. On deck we have PictoBox.
All right. See down there. So that's good. Go. So sweet. Hi everyone. For Hack Upstate 13, we went ahead and built a couch co-op game. Couch co-op, for those who aren't familiar, is basically a game where you play locally with friends and family. So I'm going to jump right into our presentation. So this here is our main screen. This is presented like on a projector or a TV, where you go through to create a code which family members join with their smartphone. This is a dungeon crawling RPG game we made. Looks like the right thing, right code. Where basically you go ahead and log in with the room code. You go through, you select a character, a couple classes. I'll click a rogue for now. From here, we have a couple points you can drop into your character. So I'm gonna go ahead and drop a couple points in, create a character. But instead of playing as a low-level character, I'm gonna go ahead and switch to one of our higher-level characters and switch over to our demo environment. This is a level 20 character we have. This here is a very MVP model of our map. The 2 players we have who would be using smartphones are these characters here, represent these letters. So we'll go ahead and we have a couple action points. We'll spend these points by going ahead and move to the right, and we found an enemy. So we use the TCG player API to pull in cards and use the names from there. We weren't able to scrape much data without looking at scraping the flavor text, so we just added some other HP, things like that. So I'll go ahead and attack this guy. Should be a couple hits. He attacked me, attack him. One more time, boom, he's dead. I'm moving on. Got some gold here. So I'm at 3 action points, and I'll let Anita take over for our speech element of our application.
Okay, so my favorite part about playing any kind of RPG is interacting with all of the NPCs. So what we wanted to do is kind of incorporate a more personalized element where you actually do get to talk to the NPCs. So right now we just have a standard merchant that we've implemented a conversation with, and we used the, I always forget the name of it, dialogue flow to do that. So we are just going to start this.
You're getting the test version of Hack Upstate RPG.
Thanks. Start game.
Starting game.
So what do we do to a merchant? We say we want to buy things. So I want to buy something.
What would you like to buy?
Well, before I buy something, I'd like to know what they're selling. So we will see. What are you selling?
I have.
And we pull this data directly from our database that gets updated whenever you grab loot from an enemy, whenever you go to other merchants. So that's why it's not outputting here, but we can see that we have boots that we can buy, we have gauntlets, we have gloves, and we have bracers. And we also have a pretty good amount of money over here. So I love shoes. So I think I'm gonna go ahead and buy boots. Boots.
Here you go. Thanks for purchasing boots.
And lucky for us, boots were super cheap, so we have a lot of money left over to go and do other things. And we'll just say goodbye to our NPC and carry on our way. Bye. Yeah.
So we have 2 action points left, so I'm going to go ahead and continue on this dungeon, moving to the right. And I met a big baddie, 10,000 HP, I'm 966, I'm basically screwed. So go ahead and try to attack it, basically killed me, and we're dead. So here's our game over screen. What we did was we pulled in, basically every time you fight an enemy, we pull the card in to your game over screen. So we see the first 2 we saw. Since it's a high level character, we fought some other enemies before. If I click on any of these cards here, I'm brought right over to the TCG website, and if I want to, I can go ahead and purchase that card. And that is the end of our presentation. I just want to throw a quick PowerPoint up here, and just our developers.
Maniku. Fez.
Anita.
Nate and Jake, who was our designer for this project. He's unfortunately not here with us for the rest of the day. Tech stack. Angular 7, P5JS. We tried to use Philip Lights. Unfortunately, we didn't have a router with us, so that was a bust. Firebase, Dialogflow, TCG player. We also built a couple tools for our teammate Jake to develop a lot of the assets for the application, characters, and treasures. Any questions? This is all natural. What?
The application was running on 4200.
Yeah, I didn't deploy it, right?
Well, is that just like I've never seen that port used.
Oh, that's the default for Angular applications. Okay. It uses Angular CLI, and that's just the default. You can change it to whatever. We did deploy our developer tool. It used Google Sign-In so that he could use it from wherever he was at to right to our Firebase database. Awesome. All right, thank you guys.
Now we have Pictobox. On deck we have Marketing Assistant.
Hi everybody. I'm Sarah.
I'm Michael. Alice.
And we're from CoVCS. We do a lot of web development over there, and we decided to do something just completely like self-indulgent and silly for our project here. Give it a sec. Oh, it's frozen. So I don't know if anybody here uses Spotify and likes to make Spotify playlists, but I know sometimes when I make one, I like to give it like a weird custom image. Is it loading or? I think it's kind of like frozen. It's got like the loading thing.
It does have the loading thing.
That's unfortunate.
Not our fault, but obviously Mac's fault.
Okay. Well, we decided to go the opposite way with it and make a little tool where you could upload an image and it would generate a playlist based on that image for you. I really want to show it to you guys because we're super proud of it. So let me just see if I can like quit Chrome and open it back up.
How does it work? How does it find the music play?
So basically what it does is, now it's actually starting to work, so this is good. You start by you going to the site and you have to authorize with your Spotify account so that we can access the API calls that we need to do what we want to do. So I'll start off by doing that here, and it just gives you kind of a simple screen. You can choose a file. I guess I'm doing the demo first instead of explaining what's going on.
No, let's go with the explanation.
So we'll start with just an image like this. something pretty and like natural. So you upload the image. Wait a little bit. While it's thinking. Hopefully it doesn't take so long. There we go. And you get a playlist. So basically, the way that we're doing this is we're uploading the images. Well, we're not actually uploading them, but we're just kind of like processing them. The first thing we do is you put it through AWS recognition, and it kind of analyzes what's in the image. And based on what recognition finds, we use a different API to find related words that would be related to it, kind of get like a sort of general idea for the kind of theme of the photo. And then we analyze like the colors in the photo, like the hue, the saturation, value, to try and think of the mood. Like, dark, like unsaturated colors would give you like a slower sort of playlist, and bright, happy colors would give you something, happier. And thanks to Spotify's web API, they actually keep track of like every track's kind of features like that. Michael, do you want to talk a little bit about what kind of stuff that they have in that API? Because you kind of did a lot of the...
Yeah, actually, it's really funny because Spotify is just really great to work with because they have so much data on their tracks. They have like a whole object for audio, like I believe it's audio description. So essentially, like the bread and butter is the balance of the track. So the balance takes into consideration like the energy level of the track, like if it has like a high BPM or a low BPM, and like a major or minor key. And balance essentially gives you whether it's a happy song or a sadder song. So depending on like the most prominent color in the image, it'll, if it's like a bright or like really saturated color, you'll get a happier playlist. If it's like a lower saturation or just a lower color in general, you'll get a sadder playlist or just even a more mellower playlist as well.
And so this just kind of gives you the playlist. I don't know if it actually works if we click play. Yeah. But it gives you 30-second previews of the songs if you want to check them out. And we wanted to have something where it would like save the playlist to your Spotify, but we didn't get to finish that in time. And do we have any time or
Okay. Any questions?
Yeah.
So it's based on basically color saturation versus like if you threw in a picture of like Barack Obama, not around themes. I mean, this is just really cool. So I'm curious to like, you're talking about images that are based on like color saturation. You put like
We considered doing celebrity recognition. We did not get that far.
Okay, that's so cool.
That's your playlist.
Alright, up now is parking assistant, and on deck is Evo plane.
Okay, so we basically were thinking, what often will happen is in most cities in the U.S., you can park on this side of the street on these days, during these certain times, and they get really confusing. It's like this side of the street on these days, but at 7 o'clock it switches, and on Sundays all those rules don't apply. We have all these different rules. We basically thought of how will we make something that tells you which side of the it automatically knows which side of the street you should be on and tells you when to move your car. So it'll determine which side of the street is legal and it'll tell you when to move. On top of this, we thought using Stay had this awesome API, and we thought, how about we just implement that in there, and then when you park your car, it tells you some crime data, like this is not a very safe spot, you might want to move somewhere else. There's been a lot of muggings over here. And it'll give you warnings about that. So I'm going to show a video of the demo first. So this is basically the home screen. You hit the Park Here button. Oh yeah, it's a button. And then it basically brings you to this compass, because the way we find which side of the street on is based on your direction. It calculates the time and then starts giving you this countdown. And then eventually this little red triangle will pop up, and when you click on that, it'll basically give you the crime data. Then there's a reset button, which will basically stop all that, and bring you back to the home page. That entire process, 15 minutes before you should switch, it'll send you a notification on your phone. So you're not completely unaware of what happens. And then also, what happens when you're on the wrong side of the street? This is what happens here. So you hit the park here button again. You get the compass again, and you point it in the direction of your car. It then will basically go and calculate the time, and then it basically says, this is illegal to be parked on this side, and you can't even park there, you have to go on the other side. So, yeah, this is basically the data structure. We have two aspects of it. We have the safety aspect, and then the parking management side. The parking management basically does is it legal on this side and reminds you when to move. And then the safety has this crime data analysis and location-based warning. I didn't work much in that. He worked in that, so Sale.
Oh yeah, so basically what we did is we used Flask written Python to be able to access all the APIs from the state API website, and so that way we were able to eventually calculate the amount of time or the most common crime that happened in that street, and related on the related by the latitude and longitude given by the user and the compass. We were able to then calculate like a specific parameters on the distances where the crimes occurred, and be able to specify the most common crime that happened in that general area to be able to then alert that to the user.
Yeah. Then we built a backup server out of Raspberry Pi. This entire thing is actually, you can get an app on your phone. We used React Native and Expo. It'll use your phone's built-in magnometer and then basically location services. Yeah, and from there, it'll tell you what side of the street you're on and when you should switch. Any questions? Yeah.
So as an end user and in the app, I just have to put the park here button.
Yeah, you just have to put parking here. It reads your latitude and longitude, and then they just sends the request, and then we just process the request, and we'll figure out the crimes that happen nearby, and then we'll just automatically do that for you.
You will have to do the compass thing though to show which direction you're going, but that's it. Just park now, direction my car's facing in. It'll do the rest for you. Yes?
Where are you getting the data to tell that the current side of the street you're on is legally parked?
Right now we're just hard coding that in there, but eventually we might use a different API or something like that. Is that it?
Now is Eagle Plains. On deck we have American Sign Language.
Okay, cool. So our idea initially, like the first idea that I had was to decrease the cost of launching things into shape by using fluid flow simulations and genetic algorithms to figure out the best shape to wrap around that object so that it's the most aerodynamic as it can possibly be.
So that's where, like, he said this idea yesterday in the introductory session, and that's where I came in. So, quick show of hands. How many of you believe in evolution here? Everyone. Yeah. How many of you don't believe in evolution? Yeah, good. So, it's just a side note, like, whether you believe it or not, evolution is one of the most powerful, algorithmically powerful things in nature. So it helps create a very powerful mechanism to solve this problem of search space. So we applied this evolutionary algorithm, genetic algorithm in particular, to the problem which he was trying to solve. So it basically has features like reproduction, and okay, I'll read it out. It has reproduction, then feature selection, and then it has crossover mutation,
and then it goes through this creation of individual, and then repeats the cycle over multiple generations while it is trying to search the search area, as in like problem solving search area.
So the first thing that we accomplished that we were really proud of is we used Blender, which is just a free modeling program to model. We used the physics simulation from that to simulate particles falling, and we could use that to calculate drag. And that actually worked. We were able to also we made an evaluation function by, we took screenshots and then calculated like, based on how much blue there were. Blue is areas where there's not a lot of movement. So we were able to calculate that way where stuff isn't moving. And that also works for really strange shapes, but we just started out with spheres for testing. And this is some of the code for the evolution thing, which we never were able to implement together with the models, but like it worked separately, and I can show you that in a second. So first of all, we have the simulation, which it does. If you do this, I have some code that I wrote that it can go through, and if you run the script, it'll tell you how much like blue there is, but then you can change it, and it'll tell you how much blue there is once you change it, so you can figure out the like coefficients that way of the drag. And then also under this file, this is where we didn't really get to implement this, but over a lot of generations, this would get a lot better. The computer was like, well, this is the first thing that I'll try. So it took our sphere and it just mangled it like this, and the idea was that over generations, it would shape into a more aerodynamic shape.
Okay, quick question. Have any of you worked with genetic algorithms before? Okay. So the basic idea here is that there will be a fitness evaluation function. Okay, so it is based on Darwin's theory of survival for the fittest. So whenever there is a population given to the algorithm, it actually, as I said, the evaluation function would be how much is the drag coefficient. So the one which has the least drag coefficient will be taken from the population. So what I did was like I took 2 of those populations and used it to create 10 other offsprings. So my population size was a constant 10 for each generation, and over a period of time, it keeps like reproducing and trying to, find the best individuals over a period of time, and then try and see which is the lowest drag coefficient model that it can produce.
Any questions? Yeah.
Did you implement any protocols for handling local mins or maxes?
We can talk about that.
So I couldn't.
Did you implement any protocols for handling local mins or maxes? Since you said you always took the best one.
No. So local mins and maxes, we can think of it if we are using like particle swarm optimization or something. But in this one, I just try to implement a very basic custom genetic algorithm.
Okay.
First, we tried using the packages which are available, but then since this needed an interface with the Blender application, so we tried. I mean, I couldn't actually get it to do it with the packages, so I just custom wrote my algorithm. Oh, by the way, you can actually combine this with machine learning, and then get to train it on itself. But then machine learning is too mainstream, so we chucked it.
Now we have American Pi language, and on deck we have synthesizing central patents.
Alright, so my name's Kevin, and I'm Mark, and we're American Pi language. We both took American Sign Language at school. We both go to university at Buffalo. So we combined our 3 favorite things, I guess, American Sign Language, Python, and Apple Pi, and we produced American Pi language.
Sure. So basically the idea behind this is that we have this piece of hardware right here. It's called the Leap Motion, which basically is an infrared sensor. It has 2 infrared cameras, and it uses that to, I can kind of give you a little preview here. it uses that to kind of generate the image that you see here. You can kind of see my face. And because it has two cameras, it's able to sense depth. So yeah, let me just. So some of the data that we're pulling out of this is you have 27 bones in each of your hands. Each of your pinky through index finger have 4 bones as shown there. I won't give you an anatomy lesson, but basically for each bone, we're given a normal vector, so an X and a Y and Z rotation that represent basically where that portion of each digit is pointing in 3D space. So we're able to use that and those normal vectors and then combine that with a neural network. So we use a little bit of machine learning, so I hope it's not too mainstream. And then basically we were able to gather a bunch of samples of what, for example, an A looked like and feed that into the neural network so that we're then able to test in real time, like hold an A up to it and then hopefully detect that as an A, a letter A, for example. So let's do.
Just out of curiosity, is anyone familiar with American Sign Language? Really? A couple people? Okay. Hope you can appreciate this.
So you can verify that we're not making up these signs. All right, so let's see. All right, so I'll kind of put this side by side so you can kind of see on the right what the camera is seeing, and on the left is what we're going to be predicting. All right, so we can start. I'll just do a few letters of the alphabet. So let's start with, let's see what it is. There we go. All right. Rid of this. We'll do A first, and then B, C, and D. Oh, so yeah, it's not 100% perfect. We do have issues from time to time. Anybody want to give me their name? I can try to fingerspell your name for you. Short names. Any name? Doug? All right, let's try Doug. So D, O, oh, hold on a second. A little bit too close. U, and G. Hold on. We lost calibration for a second. Let's see if we can get G. There's a G. A little bit tricky to keep it calibrated, I guess. It's kind of hacked together. We've got it taped to a staple box of staples up here just to keep it in place because it likes to move around with this cable here. But yeah, that's American Pie Language. Please excuse the terrible pun, or attempt at a pun, I guess.
Any questions?
Looks like you're actually reading the frame out of one particular like time frame for the sign recognition of the sign. Okay. So can you average it over time?
Yeah. So we didn't implement averaging. Well, we implemented averaging in a way. So coming into this, I had taken basic machine learning class when I was at UB, University of Buffalo, and I learned a couple of basic machine learning algorithms, but this one actually, to explore that more, this actually, on each frame that it recognizes a hand, it runs it through 5 different machine learning algorithms. What were the 5? So it does a logistical regression, a linear discriminant analysis, a decision tree classifier, k-nearest neighbors, and then just a Gaussian naive Bayes. So it runs all of those, a single frame through all of those algorithms, and then basically each one of those are going to output the letter classification that they think it is, and then I just take the mode of that for whatever letter we display there, so whichever one occurs the most often.
Okay, just to it's not the averaging of the classification which I was asking. Like, can you actually average the frames which you capture actually?
Right.
Because
yeah.
Now I see that like while you are trying to make a hand gesture, it already has recognized it. So even before you complete the action. So if you average it over like, okay, what was the person trying to do? Like, what is the maximum that he has held in a position?
So are you saying not So you're not saying classify 10 frames and then take the average of the output of those 10 frames. You're saying
No.
some other average?
No. The final frame which you need classification,
Mhm.
can you average it based on the frames which you have captured, even before you send it to the classifier?
Still not exactly sure I understand.
Okay, we can continue.
Okay, yeah, we can talk after.
What's your success rate on J and Z?
So J and Z are complicated letters because in American Sign Language, they're the only sign letters that move. So a J is this, whereas all the other letters are static, like B, C, D. So a J is this, and a Z is this. So for this, because we are classifying just on a single frame, J basically is just going to take kind of this hand signal here to the end of the letter, because that's if you were finger spelling, that's kind of where your finger would hover the longest. So that's a J, and then a Z is kind of just your index finger pointing down, which is the end of the Z letter. So the J and the Z also are not perfect, so I'm glad that the name Doug does not contain either of those letters, but you pointed out the flaw anyway, so.
Do you plan to do like actual words in the future, and if so, would you do entire sentences at once or individual words?
Yeah, go ahead.
Sentences is interesting just because the way the grammar in sign language is formed is different than English, so that would be very interesting to look into. It's definitely something to think about, though.
And words as well. We don't have any words like built into our model right now, but words are definitely something that this would have capability of doing because it gives you not only rotational data of the hand, but also positional data. So for example, like signs that involve hands moving, even if the angles aren't changing, it would use that as well. So for this, because most of the letters are static, the position isn't really important, so we didn't factor that into our model.
I don't know if you said this or not. Did you guys actually make a map of the hand yourselves, or is this?
The data that trained the model?
Yes.
Yeah, we collected all that data ourselves. Just by, we know that an A looks like this, so we held it like that and hit go, and we collected like 1,000 samples of what an A looked like and kind of loosely rotated it around to build the model. Yeah.
I'm just curious if there was anything else like that out there that software that can interpret ASL and speed out text.
So we saw a couple of papers, like technical papers that had been written about it. One of them did specifically discuss Elite Motion along with like Microsoft Connect and some other gloves that I guess you wear. So it kind of discussed the different possibilities, but I didn't actually dive deep into the paper to know if they actually did a full implementation of it. So I guess nothing conclusive that I know. Awesome, thanks guys.
All right, up now we have synthesizing central paths. On deck we have getting rich trading Yu-Gi-Oh cards.
So I pivoted, my name's Edward. So I pivoted about 3 times and eventually got to using Stay's central path data, like their routes, and combining that with P5JS to create some weird music. Yeah. So within the central path data, there is, each path has a distinct color, and each path has a large array of latitude and longitude points. So in P5JS, you can there's an add-on to create sound. So I had 3 oscillators. One was an oscillator based on the path color, and it is normalized a bit, and I had to divide it even more to keep it within ear-piercing, keep it out of ear-piercing range. Oscillator 2 is just your latitude point and longitude point, and they're both randomized a bit, or else this data is the
latitude and longitude points are really similar to each other. They're only about a few decimals off, so it without the randomness, it gets really boring. Challenges. Never used P5 before. It's a fantastic library if you've never used it. Firefox is the only browser that will run this. Chrome currently, thankfully, does block audio if you haven't like clicked it to select it, and Firefox doesn't. So I mean, you can just fix this by adding in a play button. And making the sounds interesting was a bit hard, and interacting with P5 is a pain from other functions. So, if anyone has sensitive ears, I would recommend putting that up now. Oh, and the waveform is inverted. That's about it. All right, and then it goes on for about 7 minutes. And the whole data set's over now. So, that's about it. Any questions? Questions?
I'm curious, why did you choose to use the Centro data set as opposed to any other data set?
Those 3 pivots. So originally I was going to maybe combine it with like poverty data, see if access to transportation affected poverty data from the census. And I realized I don't know R, and R would be great for that. So I just pivoted to things I like knew about, and I just kept the data set because it was kind of interesting. Any others? Okay. All right, up now we have getting rich trading video cards, and on deck we have draft combination.
Okay. So this project happened somewhere late around 3 o'clock last night when I was really frustrated converting 3D objects and trying to feed it into the machine, into the genetic algorithm, doing all that conversions. I was like, let me do something else for a while. Right? So we're gonna get rich trading Yu-Gi-Oh cards. Don't blame me if you lose money. It's all on you. Okay, so what are we gonna buy? Well, that's on the person who wants to buy. Basically, you're gonna be providing the name of the Yu-Gi-Oh card that you're interested in buying, and then the bot's gonna go through all the product listings that are there and check all the different conditions the different cards are available of that same name. And then it's gonna check the median price at which it has been historically sold. That all this data is easily available through the API. And then if the current market price is lesser than the median price, then that means that, okay, it's lesser than the average price it was sold. So maybe you can make profit when the price goes up later on. So that was basically the idea. So yeah. It's a simple logic. You're gonna buy low and sell high later on and make profit out of it. So that's basically what I just explained. And now let's try to do a demo. What? No, switch. So. Oh, my bad. I forgot to run the bot.
Can't see anything with the other screen.
Oh, but,
Whoa! They need to buy.
that's not. Okay.
Is that part of the demonstration?
No. Oh, okay. Yeah, I want to show the. Does that work? Okay, cool. So basically, this should work. No promises. Okay, so I've seen that card. Now I might have typed something wrong. Let's try another one. Maybe it's in this. Oh yeah, worked. So you have a chance of making this much profit if the price goes back up to the median value. This is the current median value, and it grabs the picture of the card and a link to buy it. Here you can see the listed median value and the market price. So kind of looks profitable if you invested it. So that's all. Any questions? Yeah.
Would you be able to go through your entire API and check which card would be the most profitable?
So basically, the API, while I was going through the API with the help of Postman and the documentation, there are two things that I noticed. One was while searching, if you are searching with a name, you have to mention the category. That's why I stick with Yu-Gi-Oh and not the different kinds of cards. So you could go through all the categories, and then I guess you could search for all the listings and then try to figure out which card would be most profitable. Then you'll be just spamming their servers with lots and lots of requests. But yeah, possible, I guess. Oh, thanks.
Up now is draft domination, and then on deck we have Sensothon.
So hi everyone, my name's Ignacio.
I'm Melissa.
We made a website here. It's draftdomination.com. It's up and running if you want to access it via your laptop, tablet, phone, whatever. And basically, as a fantasy football fan and business analyst, for a while I've wanted to create a platform to both share my insights and analysis, but also give other people the ability to derive their own insights from the work that I do, gathering data, cleaning it up, visualizing, etc. So we were successful in doing that, and here it is. This is the website, it's the homepage. We wrote 2 articles last night. They're here front and center. We have a tab that describes our process, and it's pretty simple to explain. You basically calculate the expected result of a player, their cost for a given week, so you can calculate their kind of value. And it sounds pretty straightforward, but it actually takes a lot of data mining, cleaning, and integration. So it's something that's really not readily available through mainstream channels like ESPN, NFL, etc. So, and then after this is all calculated, you have to actually be able to interact with data and create insights. So we created a number of dashboards that we host on Tableau, and they're meant to be able to interact both at the position level, the week level, team level, etc. And Melissa's going to go through utilizing the dashboards.
Yeah, so we have a few examples on here. This first one, it links to Tableau Public. We did that just for the demonstration because like it's kind of hard to get it embedded properly. There's like performance issues, but essentially this is one example chart where you have fantasy points that are earned versus salary, and so essentially we're trying to find like the cost of drafting a player for the week, and the size and color here correlate with how good of a bargain a player is. So large red circles are going to be the best bargain players of the week, and the filters on the side here allow you to see different positions once it loads, and then also change weeks as well. And when you change it, you can see the title here. It will dynamically change to show you exactly what you're looking at. And we started working to create a machine learning model to accurately predict the best bargains for future weeks. But I mean, it's a little complicated. So we didn't have time to fully tune the model. So choosing the best algorithm and optimizing that model is the next major challenge for a project in addition to creating more content for the blog itself, so we can have more fun with fantasy football.
So yeah, that's. Do you guys have any questions?
I just want to say, I just see this causing a lot of bar arguments in the future.
Yeah.
And it would be interesting because I know that like sometimes players get hurt. So I'm thinking like and I don't usually engage in fantasy football, but sometimes the argument is, oh well, if this player they lost because this player got hurt. So like if the user could say, what would happen? What would be the chances of this team winning or losing if during this point in the season this player was out or that player were out? Like so that we can kind of like mix it up and play around with it a little bit.
Yeah, absolutely. Yeah, that's a really good, like what if scenarios. So this is specifically for like the daily fantasy contest. So in a week you select your players and then you gather points based on their individual performance. So this is kind of based on the individual level. So if they had an injury designation, their expected output would be 0. So then when you would look at the dashboard, that's predicting the performance, it would be 0. So so that's kind of like what would happen with injury statuses. But yeah, it wasn't really built to kind of like the effect of a single player on a team and like how the team's performance would change if that player was missing. So this is specific. This is fantasy lineups, but that would be a really cool analysis to integrate.
That's why I put that disclaimer out there. I don't, I don't normally play around with stuff like this, but I just thought it would be interesting.
Yeah. Yeah, and the dashboards are all relatively fast, as you saw, and relatively intuitive. So yeah, my goal was to both be able to write articles for my insights, but also give people the ability to derive their own insights by exploring the data. The one that we're pulling up here explores individual players. So we're in the off-season right now, so this is all based on 2018 data, but you can see how players' performance vary week to week, both like their given price and their their salary, their performance, etc. Any other questions? Thank you.
All right, last up we have Sensathon.
So we weren't planning on presenting, but we were so inspired by everyone else's projects that at the last minute we decided to come up here, show what we made. So we don't have a presentation or anything. So we made just a native Android app using Android Studio that I don't know if anyone has played. Yeah, those toys called like the Bop It, where like it shouts commands at you.
Sure.
Yeah. They had like really obnoxious commercials when I was a kid. It always got stuck in my head. So we decided to make that on my Android phone. So it just kind of shouts commands at you, 1 to 5. So push it just means like shake it. Twist it just means rotate it. Block it, which means like wave your hand over the proximity sensor. Bop it, of course, which just means like smack it. And then so rest it, which is the hardest one because you just have to hold it still. But you're so used to shaking it that it always gets you so.
Yeah, all right, okay.
Hold on straight.
We're gonna reset it.
Twist it. Lock it. Off it. Off it. Twist it. Lock it. Lock it. Push it. Push it. Off it. Off it. Off it. Push it. Off it.
It's pretty challenging. It's harder than it looks.
Push it. Off it. Rest it.
You actually have to be kind of aggressive. We set the parameter free on the accelerometer.
Twist it. Twist it. Rest you
Yeah, and there's a running score too.
Yeah, keep track of the score. There's like a little button to reset it. If any of the judges would like to take a play, I'm crash. No? Okay, I mean, you know, we have 2 minutes. We do.
Is it in the Google Play Store?
It's not. I mean, we just made this yesterday. Anyone, if anyone wants to play it, you come see me afterwards. It's pretty fun. Any questions for me?
So, we've used Bop It at home. So there's some neurodevelopmental stimulation, some of our children. And so I think you have something here. I think you should actually market this for free, whatever. But you get into the neurodevelopmental communities. Connecting brain and physical is actually a need, helping get your mind working and body working together.
Thank you.
Would you be planning to put this up on an app store of some sort? And if so, how would you avoid getting
Very good point.
Yeah, we didn't think that far ahead. We just thought it would be funny.
We'll say press it.
Press it, exactly. I don't know, I think it's pretty similar.
Yeah.
We'll worry about that. We'll figure it out. High score. Oh, I've gone to like 60 or 70. I was playing this all night. He was at 30.
Oh, geez.
Yeah, the score goes up pretty quick.
Do you have levels? Are you getting harder?
No, we plan to implement some like trickier ones, so we're gonna have like blow it.
Yeah, you can blow into the microphone.
Yeah, so you have to blow into the microphone to get
And scream it.
And so like and the we're also but we just make it that far, yeah.
Throw your phone faster and faster.
Yeah, we can.
Yeah. It's really not that hard. We should just.
So what are you going to call the dance craze that inevitably comes out of Syracuse stuff or something?
Exactly.
Exactly.
A hackathon. Yeah.
How long do you have to input the command?
I think it was three seconds.
Yeah.
And there's also half a second of like cooldown between the two of them. Because I kept running into an issue where like you'd shake it, but it was still like moving, and then you'd switch right into rest it and then lose immediately, which was a little unfair. So we added like a little cooldown. So that like, you have half a second between the end of the last one before the next one. So maybe like I guess 3.5 seconds.
Would you implement something for it to get progressively faster? Did you guys
We didn't do that. It would be good.
Yeah.
Good job.
All right, and we're just going to have Smiter do their demo really quick because they got their laptop working.
Rather a different method.
Anyone else has had technical difficulties, you can go up and do a 1-minute demo really quick. Anyone that had their laptop die or
I messed with it. Okay. So much as we. Yep. Okay. Is that one right? Yes, it is.
So I guess just show it off real quick. hopefully it's bigger on the projector screen. Alright, so yeah, I managed to get the background on there. The character, it's got an idle animation. Something so touchy. Back. Okay. Then it changes to a running animation when it moves around.
Are you using the keyword for it?
Yeah. I mean, inputs on Java are actually pretty simple, so I'm sure you could hook up to a gamepad if you wanted. I had plans to get enemies in there to kind of chase you around, but I only just got the animations changing like at the last minute. So that's Smiter that I had for a project.
Any other projects that we might have missed, or if anyone wants to do a demo of that technical issues? Going once?
This is the bird in the car game?
Yeah. Yes. The virtual machine works. Yeah, I'm not trying to do that. All right.
Okay.
So,
Not yet.
we're getting input, and I'm happy. Yeah. I have to start the virtual machine. I'm sorry. I should probably start this before I actually get out of here. Just give it a second. The virtual machine's actually working this time, so I'm pretty bad. Okay. Yeah, yes. Thank you.
All right, we'll be back here in about 10 minutes or so. So all of the judges, please follow me. Go deliberate, and we'll be back here shortly. All right, everyone, gonna give out some prizes. Hey, prizes! All right, everyone, thanks for your patience while we deliberated there. I'm really excited to award some really, really awesome prizes. So let's kick it off here. First, we have an honorable mention to Pictobops. Unfortunately, sponsored and eligible for prizes, but we have to give you an honorable mention. So awesome work with your project, but unfortunately can't give you prizes, but honorable mention. So awesome work. All right, up next we have AAS prize, presented by AAS. Gary, if you want to come up and say a few words.
All right. So there was definitely a lot of good prizes this time. Oh, here's my prize. There was a lot of good competition this time. I actually really enjoyed most of the projects quite a bit. But one of the things that we judged on was practicality and creativity a lot. And so we actually chose the American Pie to see.
Congrats, guys.
Good job. I'll spend it all in one place.
Thanks, guys. Congrats. All right. Next up, we have Best Use of State's API using a Syracuse dataset. Crystal, would you like to come up?
So yeah, two projects, basically the synthesizer using Centro bus lines, and then parking assist. So out of those two, parking assist to me had the most extensible one, so we are going to pick parking assist.
Thank you, Crystal. All right, next up we have Best Use of Collectible Card Gaming Data. John, would you like to come up?
How's it going? So yeah, some interesting projects using our APIs this year. Some of you probably realize where our APIs can slightly improve. It is possible. I think that we're going to go with is the Project War Falcon game. If all of you could give me your email addresses who are on that team, we will send you the gift card probably on Monday when our resourceful humans are back in the office and we'll authorize all that stuff to go through. But yeah, each of you will get the $200 gift card to Amazon. And yeah, thanks a lot. That was a really cool project.
Yes, just a quick heads up for that prize here. We'll actually be getting all your emails. So John, we'll send you that after the event here. So we'll get those for you. But yeah, just a quick heads up for API prizes. But thank you. Awesome. So next up here we have our best effort hack, and that one is going to Rezi. Join us afterwards for. Yeah, sorry. All right. Next up here we have our best hardware hack. That is going to Sensathon. Congrats, guys. You'll join us afterwards here. No, it's like we should have this figured out by now. But yeah, everyone will join us at the end of the hallway here for like all the checks and all that good stuff. But yeah, let's keep things going smooth here. Sorry, folks. Doing our best here. All right, first runner up. We are proud to present to Parking Assistant. All right, guys. There was a lot of amazing hacks over these 24 hours, but only be one grand prize. So there's a drum roll in there. So should we do a drum roll? Grand prize for $1,000 goes to American Pie Language. Amazing work to all the winners. Congratulations to all the winners today. Give them another huge round of applause.
So all winners, there's a form in the front, so follow me. We're going to go to the end of the hallway, get your picture. We got some giant checks. And thank you, everyone, for coming so much. We'll see you hopefully in the fall.
Good. I forgot about this.
Yeah.
You want me to stop it? Are we good? Or?
Yeah.